Hey, good afternoon, ladies and gentlemen. It is 3:37 p.m. We are at Oakland Junior High, and we're going to do some math. So let's jump into it, POA kids. Let's get to the homework. First of all, thank you so much if you're watching these videos. They do take us some work, so we really appreciate those guys who are going out, trying to better yourselves, trying to get that homework done, and we really hope this is helping. And if there's more we can do, if there's something you want to change about this format or how we're trying this, please leave feedback. Maybe just type it right there in Edmodo, start a new thread, and we can try to respond to everything you want, because ultimately we need this to be helping you guys do the homework. So if we can be doing something better, please let us know. Without further ado, you have 6 questions for the homework tomorrow. Staying sharp 14.3. Don't forget the optional but suggested homework on the front, going through that guided assessment and the self-test. Just make sure your skills are kept up before the next test. So you're asked to solve the equation for m. Here's your answer and supporting work. Let's do a rewrite. One thing you should never be afraid of when you're doing some math problems is to do a little rewriting of the problem. So we have the 2m plus 7 equals to 11. So the first question is, well, how are you going to solve this? So actually, before that question is, what does it even mean to solve? Because if you can't answer that, you can't even, there's no point even trying to attempt this problem. If we're trying to solve this equation for m, what that really means is that we're going to try to get m by itself. So in the very end of this problem, after all this work that happens, we should be looking at an m equals blank. In other words, we're trying to find the m value so that both sides are the same. That's what the equal sign means, you know. In this case, both sides being 11, which is going to give us a way to check this later. So first thing I need to kind of decide in looking at this m is what's around m I need to get rid of, so m is by itself. I see a multiplied -2. I see an added 7. We're going to do this reverse. We're going to unpack. We're going to go backwards. So I would normally add last, but now I'm going to take care of the addition first by the subtraction property of equality. If I do to one side, I must do to the other. So I'll subtract 7 to both sides of the equation. Okay. Now the whole purpose of subtracting 7 was to cancel. Boom, canceled. Going to bring this -2m down to my equation, haven't dealt with that -2 multiplication yet. Over here, 11 minus 7, well, that's going to be a 4. That's done. Now let's take care of the rest. We have a -2 times m, times being the key thing. Don't get tricked, don't get tricked into thinking that this is somehow -2. This is a -2, but it's being multiplied, and that's the important part to our m, which tells us to get rid of it, we will be doing some division. Of course, division property of equality states if I do it to one side, I do it to the other, for the express purpose of canceling, which leaves me with an m equals -2. That's an equal sign. That turned out weird. Now, if we wanted to check this, and I'm not going to go through it, but I'll talk about it just for a second, we were looking for an m value that made this equation equal on both sides. So this expression should be equal to this expression. In other words, both are 11. If I were to take this -2 and stick it in right here for the variable, I should be able to check that. -2 times 2 plus 7. If that's 11, I'm in business. If not, it's not. But as you guys are going to check that on your own, pause the video, do it, you'll find that it does indeed work, because that'll be 4 plus 7, and that's 11. Boom, let's move on. Oh. That sudden O is because I didn't know where all my problems went, but I found them. No big deal. Let's get to work. We need to plot the x and y intercepts of the line with this equation and then sketch the line. Lots of ways we could do this. The way that you might fall back into is to take this equation and make it a y equals equation, so you guys can plot the x-intercept, y-intercept. I'm not going to do that. In fact, I'm going to know what I know about this equation and know about x and y intercepts to make this go a little bit faster. X and y intercepts occur on these axes. So if I know a little bit about what those points are going to look like, I'm going to be in business. Here's what I mean. The x-intercept, which is going to occur on this axis, means that the y value is going to be 0. The y-intercept, which occurs on this axis, means the x is going to be 0. I can exploit that fact to help me do this faster. Let me show you how. So what we're going to do is kind of consider what happens when x and y are 0. I would say this happens 2 ways. If x is 0, meaning I'm finding the y-intercept, so this is going to find the y-intercept. I'm going to pretend x is 0, and then I'm going to kind of solve this equation as it will. So something to kind of take note is that if x is 0, bam, that's gone. I'm just dealing with 3y equals 30. Of course, 3 times y equals 30, that means I'm dividing to solve, which is why those solving skills are useful. 30 divided by 3 is 10, meaning that my y-intercept is 10. So coming over here, y is 10. That's all the way at the top. So y-intercept, pretend x is 0. Substitute, bam, solve, put that number on the axis, move on. So we're going to reverse this. So if I'm going to solve for the x-intercept, that means y is 0. So I'm going to look at this equation again. This 5x plus 3y is equal to 30. That's a 30. And I'm going to now pretend y is 0. So I'm going to rewrite replacing that y with a 0. So 0 kills it. So I'm really just dealing with 5x equals 30. So 5 times the number is 30. Let's go ahead and solve because it's at 5 times 5. That's going to give me a division problem to solve. So x is going to be equal to 6. So on the x-axis, boom, 1, 2, 3, 1, 2, 3, 4, 5, 6. That's going to be my x-intercept. Now we're going to construct a line here as a sketch. Now I'm going to cheat and use a computerized line, but certainly you can too. So again, quick review. To find the y-intercept, pretend the x is 0, because that's what it is. Substitute, kills that term, solve the remainder. X-intercept, y is 0, put 0 in for y, kills that term, solves for the remainder. Pretty easy once you get to it. Let's look at number 3. Muhammad and Timothy asked you to order sodas for an end of school year party. Man, that was hard to say, wasn't it? Muhammad says that Muhammad says they need 60 sodas in all. Timothy says they need twice as many diet sodas as regular sodas. I'm going to try to organize my information. As much as I stumbled over that, the first thing you should always do is really understand what they're asking you. So I see that piece of important information, and man, do I see this one right here as well. I guess people are going on a diet. It's probably good. You shouldn't drink soda, ladies and gentlemen. It's bad for you. There's a ton of sugar in it. So diet soda, sugarless, much better for you. Soda's not good for you. I'm on a little tangent. But, if you're going to drink soda, diet soda is a better choice than regular soda. But honestly, drink juice instead. Anyway, moving back to the problem. It looks like I have 2 constraints. Constraints are nothing more than like a rule. I have 2 rules I have to follow. Muhammad's rule says I need to have 60 sodas in all. Timothy says I need twice as many diet sodas as regular sodas. So the question is, well, how many regular will you order? Well, they're going to have us kind of vet this out by looking at A and B. So A is definitely going to be Muhammad's problem. Okay, so it says, what's Muhammad's... Ooh, wrong color. Bam. So A is going to be Muhammad's problem. So I just need to state an order that satisfies Muhammad's condition. Boom, Muhammad's condition is that we're dealing with 60 sodas overall. So there's lots of combinations. I bet you're sitting there thinking, oh man, Mr. Collins, which one do I pick? There are so many. I agree. There are so many. I could order 60 regular, and that's all I'll call 60 regular. And I could also order, that would make me order 60 diet, or 0 diet, excuse me. I could also say, well, I will want 1 diet and 59 regular. I could order 20 diet as long as I order 40 regular. We could do this all day, but the point being, the rule you are following in this case is Muhammad's rule. So as long as your order follows that rule, you are good to go. And yes, there are many solutions. In fact, I would say there's almost an infinite combination of solutions. Maybe not infinite, but pretty darn close to it. That's a lot. Let's go to Timothy's rule. Highlighter. Boom. Let's go to Timothy's. So let's state that could satisfy Timothy's condition. That's fine. We could do that. His condition, if we read it up here, says I need twice as many diet sodas as regular sodas. Whoa. I mean, there's no cap to how many sodas I can buy as long as I order twice as many diet? Okay. So let's say I order 100 regular sodas. That means I'd have to order 200 diet sodas. Let's say I ordered 20 regular sodas. 40 diet sodas. Let's say I ordered 1 regular soda. That'd be 2 diet sodas. I bet the same thoughts creep into your brain. How many combinations could there be? Oh, a lot. Again, an infinite combination or maybe close to it. As long as it satisfies conditions, that's what we're looking for. Okay. Now we're going to go quickly into the next problem. It's actually related. So they wanted to reconsider the Anthony-Muhammad dilemma. And just to kind of refresh your memory, you can certainly page back, but I'll write it here. The Muhammad condition was that there were a total of 60 sodas. And the Timothy was twice as many diet as regular. So I need to find a solution that satisfies both. So wait a minute, where should I start? Well, I'm going to guess that this twice as many diet as regular is going to be our starting point. And we can make it kind of very organized. So here's regular, here's diet, and here's total. Okay, so we're going to start with this condition where I'm going to pick twice as many diet as regulars, but we're looking for this total to make 60. And as soon as we do that, man, are we in business. So might be some really targeted guess and check. Let me explain what I mean. So let's say I did 25 regulars. That means I have to order 50 diets, and that's because of Timothy's rule. That gives me 75 total. Not good. Too many. I need to change this. Well, I'm going to guess that this doubling is going to affect my total more. So I'm going to take it down to, like, I don't know, 21. So 21, that'd be 42 diet. That'd be 63. We're at least going in the right direction. We're awfully close. I'm going to bump it down one more, 20. That'd make me order 40 diet. Oh, wait a minute. That's my 60. So 60 is going to satisfy Muhammad. 20 and 40, because twice as many diet as regular, is going to satisfy Timothy. So I'm going to order 20 regular and 40 diet. Okay. Now you may be asking yourself, well, are there other combinations that work? That's a wonderful question and a very intuitive one to ask. And we're going to be exploring that as we move forward, but it's important now to realize that there is a combination that can satisfy both Muhammad and Timothy. Capiche? Let's move on. Number 5. Oh, I love number 5. Okay, a 6-sided number cube, but let's just call it a dice. That is silly. Now, I'm going to change that. Hold on, this is dumb. A 6-sided number cube, a 6-sided die, has faces with numbers 1 through 6 marked on it. In other words, it looks like this. Boom, magic of video. Has number 1 through 6 marked on it. If each number has an equal probability of being rolled, and it is if it's not a loaded die, what is the probability that one toss of the number cube you would roll each of these? Okay, so let's talk probability. Let's talk really fast. So here's the deal. If you're rolling this number cube, you do have an equal probability, an equal chance of rolling each of the individual numbers. So let's talk about probability and actually how to calculate it. It's pretty simple. That's why it's called simple probability. So check out this. The probability of an event happening is equal to the number of favorable outcomes that you actually want to happen divided by the number of total outcomes that could happen. Okay? So in other words, each of these breaks down to really understanding two things. How many dice or how many numbers could you roll, and how many possible combinations of things you want to happen are present. And that's going to be our probability. Don't get freaked out by this probability of an event. It's function notation. What? So let's talk about this guy, the number 5. So the probability that I will roll a 5 is equal to the number of total 5s there are on the dice divided by how many different numbers there are on the dice. Well, let's do the easy part first. There are 6 numbers on the dice. How do I know the 6 numbers on the dice? Because it's a 6-sided number cube. So there are 6 different numbers on one each side of the dice. Therefore, there are 6 total outcomes that could happen. Well, how many favorable outcomes are there? In other words, how many 5s are on this dice? I'll wait. There are 1. So the probability that this could actually work out in our favor, in other words, we roll it and get a 5, is 1 out of 6. Now, we could use a calculator to calculate this. Magic of video. 1 divided by 6. And of course, times 100 if we want to get a percentage. So the probability that we will roll a dice and get a 5 is approximately equal to 16.7%. Now, I'll be honest, I prefer this over this, but percentages are a real thing, and we're going to have to deal with them because that's how world kind of understands probability and chance. So, really quick review before we move on to the rest, because I'm going to move fast to the rest. The probability of any event happening is equal, simple probability, is equal to the number of happy events you want to happen, divided by the number of things that could happen. So, over here, the probability of rolling any other number but 5. So the probability of rolling a 1, a 2, a 3, a 4, or a 6 is equal to how many of those things are actually present. Well, it's 1, 2, 3, 4, 5 things divided by the number of things that could happen, which is 6. So 5 divided by 6 is going to be approximately equal to 83.3%. Either one is good. Okay. Dice, you outlived your usefulness. Okay, a number less than 3. Okay, now we're starting to get a little tricky. So let's work out what those numbers are. A number less than 3 that I could roll would be 1 and 2. Less than 3 does not include 3, so it's only those 2 things. So the probability will be 2 things out of 6 things, which is approximately equal to 33.3%. Either, again, I don't care if it's a fraction or a percentage, it's up to you. A number no more than 3. So number no more than 3. So that means I can roll a 1, a 2, or a 3. A 3 is no more than 3. So it looks like our probability went to 3 total things. Boom, boom, boom. Out of 6 possible things, which if you're playing at home, that's 50%. Over here, an even number. Let's check that out. Probability, that'd be a 2, a 4, a 6, which is 3 things out of 6 possible things. That's another 50%. Probability ain't bad, guys. It's just a division problem. It's just you have to understand what those pieces mean. So this is a thing right here. Boom. If you don't know this, you haven't committed to memory, please get that down. That is so bloody important. Moving on. Last question. Oh, probability. I love it. If the probability that it will rain on a Monday is 3/4, what is the probability that it will not rain on a Monday? Okay, so here's where we have to go back to the previous problem, because maybe at some point you're wondering how I got that second percentage so fast without calculating it. I didn't pause this video, but I want to point out how quickly I got this percentage. I know that if I take all the possible things that could happen, I now understand 100% of the things that happen. Okay? Let me try to say that again. If I list all the things that could happen, I've covered 100% of the possible outcomes. So take a look at these two numbers, or these two problems side by side. Okay, so if I roll a 5 or any number but 5, that's all the numbers. So if I look at my probabilities, they have to add to 100%. If I take a 6 and add 5 6, that's 6 6, which is a whole 100%. If I take 16.7 and add 83.3, that means that's 100%, because that's all the things that could happen. So that's the thing I got to look at over here. So if the probability it will rain on a Monday is 3/4, that means the probability it will not rain is the other 4th. So let me say this kind of differently. If the probability it will rain on Monday is 3/4, which is equal to 75%, that means the probability it will not rain Monday has to be the remaining pieces, which is 1/4, 3/4 and a 4th, which is equal to 25%. And again, the check is these guys have to add to 100%. So my answer here is 25%. I know it's a weird concept. We're going to keep talking probability this year, guys. So if you're a little freaked out about it, don't get freaked out about it. Maybe rewatch this section. Anyway, guys, thank you so much for watching this. I'm sorry I got a little crazy. I get a little excited when I'm doing math. That's just the way it is. So, if you have questions, please post them at Edmodo. We cruise it every night. Mrs. Bryan, Mrs. Norton, and I, we all look at that stuff. So if you're posting on there, we're gonna answer your question as soon as we can. This is for you guys. Spread the word if it's helping you. Get your friends to watch it. Get their friends to watch it. Hey, if you have a friend in algebra class, let them watch it too. Anybody's welcome. You guys have a great night. I will see you tomorrow.